Hello viewers, welcome to my YouTube channel. This is Sarayu. Now I am going to explain digital electronics subject for CSC IoT triple students. For btech R22, R25, R18 regulation syllabus, unit wise, all chapters, important questions. First chapter, Boolean algebra and logic gates. In that we have number conversions concept, octal, binary, hexadecimal. These are the types. In that we need to convert octal to binary, binary to hexadecimal, decimal, binary to hexadecimal. In that we have three types. In that we have 8 sub concepts of changing one type to another type. Another concept, complements concept. In that we have ones complement, twos complement, nines complement with examples. Ones complement, if a Boolean equation is given like this 1 0 1 0 1, then we need to convert ones as zeros and zeros as ones is known as ones complement. For twos complement, 1 minus ones complement is known as twos complement. Nines complement, in that we have nines replaced with zeros. Boolean expressions, in that we have Boolean theorem, properties and functions with examples we need to explain in detail, like a into b plus c dash c naught. We need to convert with some properties into another format is known as a Boolean expression, and or not into or not conditions we use in that case, and we will simplify the given equation. In some cases they will give LHS and RHS. We need to prove LHS equals to RHS. Solve the problem. If you get it answer, you can write equals to RHS. If you not get the answer, simply you write LHS equals to RHS. For doing this method, you will get good marks. In some cases, they will ask for one more questions like what is Boolean expression. Then you need to write definition with some example like a into b plus c dash plus d e f dash, like that. Binary numbers, in that we use logic operators. We need to write definition, codes 0 1 1 0 1 1, like that. Register and storage, in case of binary numbers. Logic gates, in that we have universal logic gates and or not, basic logic gates. We need to write all those functions, and we need to write types with tables. For and we need to multiply. For or we need to add. We have exclusive or terms like XOR, exclusive or, like that. Logical operators by using and or not conditions. Important questions like verify expression AB plus C plus D into another component C dash plus D into C dash plus D plus E equals to AB into C dash plus D. We need to verify LHS equals to RHS by using some properties. Is known as a Boolean expression. Perform 1110111000 minus 00110000. For subtracting, there is no direct formula. In case of binary, we need to convert this into ones complement by replacing 0 as ones and ones as zeros. By writing it ones complement plus 1, we use this formula for subtraction. Express f of a function a b c equals to a plus b dash c as sum of minterms and canonical form. We have canonical form, in that we have sum of minterms, sum of maxterms. For minterms, one output is there. For maxterms, another output is there. By seeing sum of minterms and maxterms in canonical form, we can solve this concept questions. Simplify the Boolean expressions to minimum number of literals a plus b into a plus c dash, b dash plus c dash. For addition, we can convert it as multiplication. Some properties are present in Boolean expression. By using the properties, we can simplify the given equation. binary conversions on basic conversions, number conversions, they will ask like that, convert. This is decimal format. We need to convert it as hexadecimal, base 16. Base 10 to base 16. We need to convert. Is known as binary to hexadecimal. Duality. For simple equation, we need to add a dash, is known as duality property. We use this property in Boolean expression, and you need to write example for this duality property. Find the equivalent gray code for 10110 for binary. Outline the concept of duality Boolean algebra. It is important question. They asked this question in 2 question papers. By using Boolean algebra concept, like a plus b into c dash plus d, by using this equation, Boolean algebra, we will convert it as a dash plus b, there is no dash, so we need to write dash. For c dash we need to write c, plus for d we need to write d dash. It is a duality property of Boolean algebra. Write its important and write its example. Minimize the following Boolean expression using Boolean algebra and draw a diagram. X dash into y dash z plus x dash y z plus xy dash. For plus we need to write OR gate. For multiplication you need to write AND gate. Straight line. For NOT, bubble will be represented. This is for x into, this is x, this is y, both in multiplication, so we need to write AND. For bar representation we will represent as bubble. Perform the BCD addition of 375 and minus 267 binary coded decimal concept. By using that concept we can add the numbers of 375 and minus 267. What are universal logic gates? Implement XOR gate using universal logic gates. Logic gates are universal logic gates and or not. For that we need to write table formats. For AND, inputs like 0, 1, 1, 0, 1, 1. Take 2 inputs. For multiplying, 1 into 1 is equals to 1, 0 into 1 equals to 0, 1 into 0 equals to 0, 0 into 0 equals to 0. In AND case, A and B are inputs. For AND condition, AND is denoted by like this, AND A type. For OR we need to add. It is like V shape, reverse V, and like A not attaching with the line is known as AND symbol. This is OR symbol. We need to add it. 1 and 1 adding, 1 and 0 adding. For 1, 0 and 1 adding 1, 0 and 0 adding is 0, 1 and 1 adding is 0. We need to write these in table formats. Is known as universal logic gates. For NOT, it is represented with negation format. For 0 it is 1, for 1 it is 0. This is A, this is B, second input. We get output. A is input, B is output. In case of negation we will take as 2 inputs, 2 outputs. For AND and NOR we represent it as taking 4 inputs, 4 outputs, 4 A values, 4 B values. Then we will get 4 values outside for multiplying, additioning. And obtain 3 level NOR implementation of CD into EF. For this we need to implement a NOR implementation for 3 level. Second unit. In this there are 3 important topics: K-map and logic gates. Another concept is NAND NOR implementation. In these three concepts, they will ask questions like this. Using K-map method, reduce the following Boolean function f equals to summation of m 0, 2, 3, 6, 7 plus d don't care condition 8, 10, 11, 15 and obtain minimal SOP sum of products. Another concept is product of sum. For one concept we use small m, for another concept we use capital M. This is don't get condition. We need to do this inputs for 2 power n formula. We can get K map 2 power n formula. For 4 inputs we get 2 power 4 equals to 16 boxes. We need to write it as 4 horizontal, 4 vertical lines. We need to implement the conditions. Don't care condition we will represent as x. For this condition we represent as 1. We need to perform minimal sum of products. Another concept, plot the following logical expression. An a 4 variable K map f equals to a b dash c dash d plus a b dash c plus a b and release the sum of products using only NAND gate. For NAND gate it is not plus and equals to NAND gate. By using NAND gate representation we need to perform the given equation and we need to solve it as sum of products. Another concept, simplify the following function f using Quinn's MC-Klasky method. F of a comma b comma c comma d, these are inputs. Taking inputs equals to summation of m 1 2 3 7 8 9 10 11 14 15. For these numbers we need to draw K map and these numbers represented with 1. There is no don't care condition. There are 4 inputs, so we need to draw 2 power n formula by subtracting n place with 4 equals to 16. 4 inputs, so we need to draw 16 boxes, 0 to 15 values. In place of these numbers we need to represent it as 1. For horizontal, for vertical, for 4 values we need to draw mapping. This concept similar to this question also. You need to practice universal gates, logic gates, and how we doing K map sums, sum of products, sum of product of some concepts by using 4 variable, 3 variable, 5 variable K maps. By using these 3 topics you can score 12 out of 12 marks in this chapter. Another concept is give example of any simplify equation and logic equation. Write an equation in Boolean function, Boolean algebra function, and you need to simplify it by using logical equations, logical functions properties. This is the answer for this. Explain pair, quad, octet loops using K-map. In K-map we will pair mapping for 2 variable, 3 variable, 4 variable, 5 variable. So we need to explain in this question. Any K-map sums, they will compulsory ask K-map sums like 3 variable, 4 variable. Single bit comparator with example. It is for 1 mark question. It is used to compare the value single bit. Don't care conditions are used in K-map. And draw any K-map. Write any equation with a keeping like this. Don't care condition for variables inputs. Then explain with don't care condition. Prove that the logical sum of all minterms of a Boolean function of 2 variable is 1. Explain it in detail. For logical sum of all minterms of Boolean expression of 2 variables is 1. It is correct or wrong, we need to explain. Performing K-map, we will take 4 variables a into b, ab, 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 a bar into b, a into b bar, a bar into b. Like that we take four values for m0, m1, m2, m3. These are the examples for logical sum of all minterms of a boolean function is variable is 2 is 1. We need to add it in first step. For example, a into a bar property equals to 1 for a into 1 plus a bar into 1. A into 1 is a bar into 1 is a plus a is 1, a into a bar adding equals to 1, it is a property. This is an example for proving logical sum of all minterms of boolean function of two variables is 1. This is an example for multiplying one element with its complement. In case of addition or operation, it is equals to 1, like b into b dash, b plus b dash, a plus a dash, c plus c dash equals to 1. It is an example for two variables is 1. Explain K-map in detail. First we need to write an example. Then for drawing we need to apply formula, 2 power n formula, write it in detail. Then we will take inputs like a bar, b bar, a bar into b, a into b bar, a bar b, like that. Doing process, write in step by step manner and write it in detail. Solve by using any simple taken given information or according to given information, or write an example with your own words. For getting marks, this much knowledge is enough in this chapter. By learning logical gates, you can attempt all questions, and by using K-map, you can attempt all questions. In first and second chapter, Boolean functions, Boolean expressions, logic gates we use in all concepts. In case of third chapter, we need to know adder, subtractor, full binary adder, full binary subtractor, half binary adder, half binary subtractor with the diagrams. What we are doing it in detail, explain with the diagram. And multiplexer, demultiplexer, like 4:1, 8:1, 16:1, demultiplexer, encoder, decoder concept, generator concept, adder, full adder, half adder, and by using diagrams we can explain it in detail. Logical sums, minterms are included in this chapter, third chapter. It is easy to score marks. When comparing to other chapters, third chapter is easy to score marks. For knowing one concept, we can learn another concept like multiplexer is opposite to demultiplexer, adder is opposite to subtractor. Like that we can attempt easy questions in this third chapter. Learn the basics, then you can attempt any question. 5 to 32 decoder, 2 to 4 and 432 decoder, 3-bit magnitude comparator. By using comparator also they will ask multiplexer concept, 4:1 multiplexer and other multiplexer comparator. Difference between encoder and decoder, diagrams in tabular format. Difference with example, one side is encoder, another one side is decoder. One side is multiplexer, another side is demultiplexer. You need to explain it in detail with diagram. By using diagram and explanation, you will get good marks. Adder, subtractor, full adder, half adder, generator and checker. It is used for scoring one mark question concept. Parity, generator and checker. Operations of full adder, operations of 4 into 1 multiplexer, 4 inputs, 1 output multiplexer. 2 power n equals to 1, 1 equals to 2 power n. Multiplexer and demultiplexer conditions with the diagrams. Prove that the logical sum of all minterms of a boolean function of two variable is 1. It is important for second chapter. This is second chapter question. These are the concepts of third chapter. Easy to score marks. Compared to other chapters, second and third are easy to score marks. By practicing these two concepts, oral concepts, you can score 12 and 12, 24 marks. Easily you can pass. In case they will give tough paper like that, you need to practice 4 chapters. For 10, 10, 10, 10, 40 marks, simply you will get 30 marks. Above border marks you will get for practicing 4 chapters. For scoring marks, you need to practice 5 chapters. Oral concepts. In 4th chapter, explain shift registers and its types. It is important question. JK counter with states 3, 4, 6, 7 and 3. Mod 6 counter, flip-flops, T flip-flop, T flip-flop concept is important. They will ask like this, JK flip-flop also. It is important. Taking input X, output Y. With using diagrams, they will ask questions. We need to draw it in sequential circuit explanation and show it in JK flip-flop. Like one input X and output Y. We need to explain it in detail. Sequential circuit with a clock. Explain it in detail. By using clock, we can implement this concept. Hold time. It is waiting time for input values. Hold time is nothing but a waiting time for a particular input or for clock pulse is known as hold time, waiting time. In some cases they will ask like this, flip-flop, decoder, counter, synchronous counter and types. By using diagrams we can explain it in easy way. By using diagram, the invigilator will understand the student has more knowledge about this topic, then they will give you good marks. Remember one thing, you need to practice all concepts. By learning all concepts, you will get 5 chapters knowledge. In that you will get 40 marks easily. For attempting 60, you will get 40 marks with the jntuh correction. Draw the logic diagram for a 5-bit serial load shift register using DEF and explain. By using flip-flops and JK flip-flop and other flip-flop concepts, shift registers, counters, trigger concept, sequential circuit, these are the topics they will ask for long questions. For short questions they will ask like what is flip-flop, what is counter, what is synchronous counter, ripple factor, in which cases we use sequential circuit, what is leveling trigger, explain latches and types. These are the questions they will ask in 4th chapter. It is somewhat effort keeping chapter for scoring marks. When coming to 5th chapter, it is important of learning RAM and ROM differences and organization of data, organization of RAM storing and ROM storing, cache memory. It is related to software components, cache memory, memory hierarchy concepts. We need to draw hierarchy and we need to explain each step with detail. Boolean functions also they will ask in this chapter. RAM ROM concept, PLA PAL, these two concepts difference in box format they will ask for long questions, 5 marks. Full adder using PAL, logic array question also they will ask in this chapter. It is also effort keeping chapter for scoring marks. Clock sequential machine using JK flip-flop, state diagram like shown in figure, state reduction if possible and make proper state assignment. You need to learn state assignment concept. By using state assignment concept we will Reduce these steps. Question, gray code definition, and equivalent gray code for given function. We need to reduce it by using gray code. And it is important to learn duality concept. It is a property of Boolean. We need to learn duality concept in Boolean algebra topic. They will ask for one more question like what is the subject name, what is the use of it, digital electronics, what is digital electronics, what is use of it, in which cases we will use this concepts. They will ask for one more question. In third chapter, one bit comparator, how it works, what is a comparator, what are types in comparator, parallel binary adder, in which cases parallel binary adder is used, and statement. With the concept, you need to explain 2 to 3 points from a short question. HDL, hardware description language, in which cases we use this hardware description language. What is the use of it? We need to explain in 3 to 4 points for short question. These are the questions for scoring marks and for regular and supplementary students. Cover these topics for getting good marks and subscribe to my YouTube channel. Press bell icon. Comment in comment section if you need any resource like PDFs or important questions or any explanation. Definitely I will help. Thank you for watching. Share this to your friends and family members.